far, we have talked about this motion. We have talked about this motion. We've even talked about this motion. Today, we get to do this. We get to talk about an object flying through the vacuum that you can breathe in two directions. This is called projectile motion. So anytime that you have an object flying through the vacuum you can breathe in both the x and y directions, two directions, we are going to call it projectile motion. And there is a basic strategy for solving a problem in projectile motion. You list what you know in the x direction, and you list what you know in the y direction. The reason for this, we're going to talk about right now. So, tell me something we know about an object flying through the vacuum that you can breathe. Tell me something we know about either the x direction or the y direction, please. Zach?
In the y direction, acceleration is negative 9.8 meters per second squared.
This is an object in free fall, right? So we have already determined that the acceleration in the y direction equals negative 9.8 meters per second squared. This means we are in free fall, and we can use UAM. We can use the uniformly accelerated motion equations. Great. What about the x direction? Who can tell me what the acceleration in the x direction is? Your shot. It's not. In the y direction, it's negative 9.8 meters per second squared. It is not that in the x direction. In the x direction, Eric?
There's no acceleration.
There is no acceleration. The acceleration in the x direction is equal to 0. The object is moving at a constant velocity. The acceleration in the x direction equals 0. It's moving at a constant velocity. In other words, you can use the equation for a constant velocity. The velocity in the x direction equals delta x over delta t. Rather than UAM, uniformly accelerated motion, we have a constant velocity. To talk about that a little bit further, notice when I drop the ball, class, does it move left or right?
No.
No, it doesn't move to the left or to the right because there's nothing accelerating it to the left or to the right. The same is true when I throw the ball as such. There is nothing accelerating it to the left or to the right. Rather than maintaining a constant velocity of 0 in the x direction, it maintains a constant velocity in the x direction. Please enjoy. Good morning and I'd ask the question, did the ball move to the left or the right, class?
No.
In the same way, it maintains its constant velocity of 0 in the x direction. Here, it's going to maintain whatever velocity it has in the x direction. It will just be constant. So it does not accelerate at all in the x direction. Returning back to the y direction, uniformly accelerated motion, there are 5 UAM variables: velocity initial, velocity final, change in time, the displacement in the x direction, or displacement in the x or y direction, and acceleration. One of those is a scalar. The other 4 are vectors. Please remind me what a vector is. Maxim.
A measurement with magnitude and direction.
Has both magnitude and direction, and a scalar, Peter?
That's just magnitude.
Has magnitude only. Which of the 5 UAM variables is a scalar? Austin. Time. So the change in time is independent of direction. So whenever you are solving a projectile motion problem, you are solving for the time in one direction, using it in the other direction, because time is a scalar and it's independent of direction.